Right, in this video in section 11.3, we're going to look at question number 4. Here we have two children sit on a seesaw in perfect balance as shown in the figure. Write an equation relating the weight and the position of a child sitting on this balanced seesaw. Okay, so we have the one child on the left, right, weighs 50 pounds and is sitting 8 feet here from the fulcrum, and then the other child is weighing 100 pounds and is sitting 4 feet away from the fulcrum, and we're told that this seesaw is in perfect balance. Okay, so up here I've just labeled the weight of the kids as x and the distance they're sitting from the fulcrum as y. And like what we saw in question number 3, here we notice, right, as the weight is increasing, right, their distance to maintain perfect balance from the fulcrum is going to go down. Okay, so this is suggesting inverse variation. And so notice if I look at the product of the weight and the distance, x and y, well, 50 times 8, that's going to be 400. And likewise, 100 times 4 is 400. Okay, so this all is telling us then that more generally, if I take the weight times the distance, I'm going to get this constant value of 400, which I can then go ahead and write as y is 400 divided by x. Alright, so that gives us an equation relating the distance and the weight. The last thing I want to say here is that this relationship between distance and weight goes back all the way to 250 BC. It was a discovery of the ancient Greek mathematician Archimedes, and it's what's known as the law of the lever. So more generally, if you have someone, say, on the left that's lighter, so smaller weight, right, and they're sitting a certain distance away from the fulcrum, right, then in order to maintain perfect balance, right, if this person on the right is heavier, they're going to have to sit closer to that fulcrum, right? And that is just represented in this equation here, right? The smaller the weight and the larger the distance, right? If I'm going to maintain equality here, then I'm going to need, right, to increase, say, the weight. That would then yield a decrease in the distance. All right, great. That's a good place to stop.